Hello. Assalamualaikum. Okay, where are we? Do you hear me? Somebody respond. Hello? Arifah? Arifah Fauzi, do you hear me? Can you hear me clearly? Okay, okay. Kita kat mana? Oh yeah, we just finished. What is it? Momentum, sorry, Indonesia. Oh yeah. Here we are at previous class, momentum. Okay, momentum. So now you know what momentum is. Yeah, momentum got something to do with inertia. They are almost the same, but the only difference between inertia and momentum is inertia only talk about um, uh, a motion at rest and at uniform velocity. But initial talk about mass too. The only difference is initial do not combine both mass and the motion, which is momentum. They combine between mass and the motion, that is velocity. How do they combine? They multiply between both. So this is why they get this, the formula for to find momentum when they multiply the mass of object with the velocity the object is, the motion the object is. Okay, so you not get confused between inertia and momentum. In inertia there is no formula, while in momentum there is a formula. Okay, they are different, but still they can be relate. Now, moving along. Okay, this activity we have I had expressed to you. I had expressed to you, you know, the idea from this activity, in order to prove to you, if the mass is higher, the momentum also higher, correct? Take a look at this last sentence here. Objects with larger momentum are more difficult to stop. This is the effect of what happen if the object have larger momentum. It is difficult to stop, as it is difficult to be moved. Okay. Now coming to this question, related question, example. We got a lorry with mass 20,000 kilogram. Remember what I told you again and again. Please put a label. Once you read, put a label. Do not make your reading go to waste. Because this we do not learn language, you know. We learn physics. Okay, mass, we know already the symbol for mass is m. 20,000 kilo moves with a velocity. Okay, underline that too. We know the symbol for velocity, v. A car of mass 2,000 kilo. Okay. Oh yeah, you know what? We got two mass here. We got two mass. If I put m here, in next calculation, in the process, you might get confused which m it is, because both use the same variable. So to differentiate between both, we have to alter something lah. So this m here refer to lorry, and we take this L and we put it at the end of the symbol, ML. Okay, and this, because of car, then we put MC. C stand for car, like that. You got the idea? Must differentiate between two, so you might not get confused. Move with a velocity of 30 meter per second. These two, we got 2v. So for you to not get confused, you must put the symbol. Where does this coming from? Okay, L, it's coming from lorry. While this VC, the motion coming from the car. Okay, now the question, what is the momentum of the lorry and the car? Oh, simple one. What is the momentum? You underline that one too. What symbol that you going to use for this momentum? Remember the symbol? Here it is. Momentum, we use symbol P. So P it is. Uncapital letter for P. Okay. Never use capital letter for P, because capital letter for P means for other physical quantity, and that is pressure. Okay, you'll find it soon. So small letter P here refer to momentum. So be aware of that. Once you come to put a symbol, be careful, because you might get confused. If you use a wrong symbol, you might get confused. Solution. We don't need to come to this. Just act like there is no solution for you. The solution coming from your understanding. Okay, you understand it already. You know how to find the momentum. You go along with your understanding before you come to see the solution. So let's begin. Now I want to find the momentum for lorry. Since it is a lorry, so this is why I use this symbol, PL. Stand for momentum for L, lorry here. Lorry equal to ML. See how I made up the how I make up the symbol. And we know the formula for momentum. We take the mass of the object, we multiply with its motion, and multiply with the motion of the lorry, of course, not the other thing. Just like that. So now we're going to substitute the value. We know the value of ML, which is, here it is, 20,000 kilo. And at the same moment, remember to be careful with the unit. Maybe the unit presented not in the basic, not in a SI unit. So once once the unit not in SI unit, cannot be used in any formula, cannot be used. In this case, we are lucky because the unit is already in SI unit, kilogram. 20,000 kilogram, and substitute the value of VL, 22 meter second -1, like that. Okay, until here you know what to do already. Okay, we're going to multiply the digit, whatever that it is, there is. Okay, here is my advanced calculator. Got 20,000 multiply 22, 440,000. What a big momentum it is, 440,000. Okay, remember we're going to deal with the unit too, kilogram meter second -1. So we combine them, -1, just like that. Okay. But you know what? This this unit is too long. We have a short unit for this momentum, as we learn the unit for weight, the unit for Newton. So you can use short unit as this, Newton second. Newton second. Notice that this second has no -1. Newton second. Okay. Okay, now we find the momentum for car. We're going to use the symbol for car. For car, MC, VC. MC refer to here 2,000 kilo, 2,000 kilo, and VC is 30 meter per second. 30 meter per second. Okay, press your calculator. Multiply 30. Okay, 60,000. Only 60,000. Wow. What the difference between momentum of lorry and a car. Okay, we can use shortcut here. Newton second. You need to memorize, memorize all of this unit. Know how to replace with short one. Okay. So you see, take this moment to see the difference. How big, how many times this momentum of lorry compared to momentum of the car. How to find the ratio? How to find the ratio? You divide lah kan? You divide this, take this, divide by this. And you're going to find how many times. For 0.000 divide by 60. 0.000. Wow, look at that. Sorry, it is 7.3, 7.3 times larger than momentum of car. So never ever get hit by the lorry. Because you're going to get the impact 7.3 times. You understand? If got no choice, you rather choose being hit by car rather than a lorry. So we come into this B. If the lorry move with the same velocity as the car, what is the momentum of the lorry? Okay, how to find momentum for the lorry? If the lorry move with same speed of car. Somebody, do you know how to make up the formula? How to make up the formula? L YL, because we refer to lorry, momentum of lorry. We got we need to have mass for lorry, which is ML, correct? But this time, remember, the question asks if the lorry move, the speed of lorry is as the car. So this time we have to take this VC instead of VL. Okay, that is 30 meter per second. VC, we put the label first. Okay, like that. Now, let's substitute what there is. ML is still 20,000 kilogram. And VC is the car speed 30 velocity 30 meters, blah 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 blah. Okay, now multiply. Press your calculator. 20,000 multiply 30, and we got 600,000. Wow, 600,000 Newton per second. Not Newton per second, sorry, Newton second. Newton second. Oh wow. Before the story, so you see, the lorry move with lower velocity than the car. But even so, the momentum of lorry is higher, way much higher, 7 times higher than the momentum of car. Even the car move faster than the lorry. But if you want to make it fair, we can make the lorry move with the same speed as the car. And guess what? Still, the momentum of the lorry is way much larger than the momentum of car with the same speed. Both the same speed. So you see, if they move with the same speed, how many times? 6,000 refer to 60,000. It is 10 times. 10 times. Wow. So it is, as I said earlier, it is rather you've been hit by a car rather than by a lorry. Yeah? Okay. So with this simple simple exercise, I believe you got the idea lah, how to use, when to use the formula of momentum, how to compare, and so on and so on, and what the factor effect the momentum. There are two factors affect momentum: the mass of the object and the velocity of the object. So now we come to application of the concept of momentum in daily life. So what is the use of this momentum? You know what? You can do your mini work at home. How about you try to type this at Google search. Google search, you type the application of the concept of momentum in daily life. Press enter and you'll see the answer yourself. Okay. This is only one of them. There are so many application of momentum in our daily life. We'll see how momentum help in our daily life, and also be disadvantage of in our daily life. Sometimes we need momentum, sometimes we do not need a momentum. You see it for yourself. You got big door to see the whole world, that is Google search. Applying the principle of conservation of momentum in collision and explosion. Figure blah 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 show the two firemen putting out a fire. In figure blah blah blah, both firemen are thrown backward. Oh, so this is how they use the English. Fireman putting out a fire. Kalau kita nak sebut macam mana ni? Fireman erase the fire. Okay. Fireman, this is how they use the English. Fireman putting out a fire. Both firemen are thrown backwards. These two, how they use English. What we say this in bahasa, kita panggil apa ni keadaan macam ni? Kita tertolak ke belakang. Okay, this is how they. So you will learn English instead of physics. Thrown backwards when water at high speed gushes. Ooh, another new word today. High speed gushes. Gushes, do you know gushes? Oh, gushes. Apa dia dalam bahasa Melayu ni? Gushes ni macam apa? Meluru keluar ke? Meluru keluar. Atau memancut Memancut Water at high speed gushes. Oh, kita boleh guna ni in our English. Out of the hose. Okay. Why does this happen? Sebab apa? Macam mana kedua ni boleh tertolak ke belakang? Thrown backward. Bila ayat ni ke depan. Tapi dia punya thrown backward ni tak berapa terasa lah kan. Jika ayat yang keluar ke depan ni, dia pergi perlahan kan. Go slow. So the fireman go thrown backward more if the high the velocity here. You got the idea, eh? The high the velocity of water gushes out, the more the fireman thrown backwards. Okay, this is actually this is not application. It's supposed to be the phenomenon. We do not want this effect, but it tend to happen because of the phenomena, not because of the we apply it. Okay, you got the idea? So the why they also been thrown backward is because not only because this water gushes out with high velocity, but also the volume, the mass of the water is high, because the diameter of the end of the pipe is big is what make the water flow with a big mass for the rate, a big mass for the same rate. Okay, what is this? Water gushing out of the hose at high speed has a high forward momentum. Due to this, two or more firemen are needed to balance the momentum by holding the hose tightly. Okay, this is how you say things about this. Okay, now moving along, we got next activity to investigate the principle of conservation of momentum. To investigate principle. So I believe this is your first time encounter the word principle. Okay, principle of conservation of momentum. That you must learn to before we end up this chapter. Momentum. So there is this arrangement of the activity. Going to do the activity and we got trolley A, we got trolley B. We got a wooden block here. We got a runway. We got a ticker tape that you know already, the use of ticker tape to study the pattern of the tick on the tape. Tick on the tape. Okay. Yeah, basically you know what will happen to this. This remain at rest. This remain at rest while this moving with certain velocity, and you know what will happen? They will collide. This trolley will knock off, will hit this trolley, and then either they will moving together along, or they will moving along, they will moving toward with either separately or intactly. Okay, and then you're going to repeat the process, but this time with two trolley hits one trolley. What is the idea from doing all of this? What is the idea? The idea is we want to study if the bigger what will happen if things get heated by bigger mass? Because you see, this we got one mass only, while this we got 2 times mass, whatever the mass is. But the idea is 2 times, because 2 trolley here hit the same trolley. So what will happen to the momentum? Will they will they preserve the value of momentum? Example, we need to go more detail about this. Example, if you know what this has, you can calculate this momentum, correct? Momentum of this trolley. How to calculate the momentum of this trolley? We take the mass of this trolley, and then we multiply with the motion the trolley is, correct? Okay, so we get this PB, PB, the momentum for this trolley. And how to find this momentum of this trolley A? You're going to do the same, correct? You're going to take the mass of this trolley, you're going to multiply with its velocity. Then you'll get the momentum for trolley A. And then you know what? And then you're going to add both momentum, PA plus PB. So you have PA plus PB to find total what? Total momentum, total momentum. But you do this before. You do this calculation before what? Before trolley A hit trolley B. Okay, this formula coming before the incident. And then after they hit each other, okay, so I put the symbol there, the symbol of equation. Will they both preserve the value of this? The value of this. Let's say the value of this is 10. 10. Okay, let's say will they, after they hit each other, will they, if we calculate back the momentum, will we get the same value as 10 here on the right side? If we got the same value as the left one, if we got the same value after and before the incident, before the hit, the same value, that telling us that the momentum is conserved. Do you know conserve? Do you know conservation? Somebody? What is conservation? Hello? Have you ever heard the word conservation? I believe you do in science form 1. Have you ever heard this word? The conservation of energy. Conservation of energy. I believe you learn about this in form 1, conservation of energy. Conserve means the value remain the same. Okay, conserve. Okay, and so does this conserve apply here? Apply here. Not on the energy, but we can talk about momentum too. either it is conserved or not before and after collision, before and after the hit. So now after this trolley hit this, also we need to recalculate the momentum of each trolley to see either that this on the right side here remain the same value as the left one here. Okay. So that is the idea. These two we going to do the same. We're going to calculate this momentum. We're going to calculate this momentum. This momentum this time is the mass is 2 times, correct? The mass 2 times. We put in the formula P equal to mv. M going to be 2 times. Okay, while V maybe remain the same. So we're going to have the same two, PA plus PB before the incident, and after the incident we're going to recalculate it to find out either they both conserve the same value. If they do have the same right side is equal to left side, we say the momentum is conserve. Now we have this table. You know what to do with this table. You're going to fill with the data while you do the activity. Okay, blah 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 blah. Systematically, and then you're going to find out either this before. Take a look at this division of column here. This column is for before division, while this column is for after collision, after the hit. Okay, and then after you put all the data here, and then you do calculation like this. You do calculation like this, and guess what? Make advanced guess before we get the value. Make advanced guess. How do you compare this value with this value? How do you assume that this value compared to this value? And guess what? This value will remain the same as this value. If this value we got 10, this also 10. If this value 20, this also we got 20. Because yes, it is, the momentum is being conserved. Okay, that's a quick idea for you lah. Before it's supposed for you to run the activity first before you come conclusion. But because of this we staying at home, so this is why we need to do the opposite way. We come to conclusion before we run the activity. Whatever it is. Until now, do you have any question? No. Okay, moving along. In activity 2.11, you may find that the total momentum before and after collision differs slightly. Only a slight. Only a little differs. You know differs. Okay. Yeah. It means that actually you will not have the same perfect value as this before and after. Let's say this is 10. This going to be, I don't know, either higher a bit like 10.1 or lower a bit like 9.2. Okay, almost the value as this. Why? Because this difference is due to external forces such as friction. Because we have friction in our our real work, we cannot run away from friction. We always have a problem with friction for moving things. That cannot be compensated completely. Okay, compensated, do you know? Compensate. Mean we get rid of this friction perfect, 100%. No. We want to get rid of this friction. We want to cancel this friction, but guess what? There is out of our ability to totally 100% cancel all the friction. All that we can do is lower as much as we can the friction. So this is why you will always find out any experiment that we do, will the answer, the value differ slightly lah. Okay. Oh yeah. Coming to this, from this understanding, so here it is. Remember this? We can, from this understanding, from this activity, that we want to see either the momentum before and after or the same, we kind of arrange some of this formula, So guess what? How to find this PA? We take MA, we multiply with VA, correct? SI, or we can replace them with the component. Let's say A here is 1, and B here is 2. Okay, so we have M1 multiply V1 to find P1, PA, P1, plus PB, M2, V2, correct? Equal to PA, because before the collision, we use U to state the velocity, because they are initial velocity. We use U, not V. Okay, sorry for that. Okay, we use U1, U2. Okay, and after the collision, we going to use V, shall we, instead of U? Okay, V, because final. So M1 remain the same lah, the same mass, correct? Before and after, the same mass. Okay, they will not change. They will never change the mass. What will change to them is only how they are motion. Okay, we got M1 V1 plus M2 V2. So guess what? We have made our formula to show that the momentum is being conserved. So as you can see at the back here, and here it is figure 2 point blah 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 shows a system of two objects before and after collision. The principle of conservation of momentum states that the total momentum before collision is equal. There is what when the symbol of equal coming from, to the total here means we have plus here, plus. Okay, total, we add both. Momentum after collision if no external force is acting on it, means external force here refer to no friction, no air resistance, nothing disturb them. Okay, nothing disturb them. Nothing disturb them while they're doing this. While they're doing this, nothing disturb. Okay. Nothing disturb them. Okay. No fly coming. Put a little weight there. No. Nothing at all. Okay. And when there is no external force, the equation will be conserved too. Okay. Means it is valid to use this formula. Okay, if there is external force, this formula is no longer can be used. Okay, you understand? So next we have this. Let's read about this. Who do we got here? Aina Fakihah. Ada Aina Fakihah, boleh baca? Aina Fakihah. Okey, Aina baca itu. Baca kejadian ini. Kejadian ini. Aina? Ya. Okay. Okay, thank you for that. Do you understand? Do you understand the statement? What he trying to tell you? Do you understand? This time we talk about before we talk about collision. Collision, which the collision is something hit something. Okay, but this time we talk about explosion. We talk about explosion because momentum apply to both collision and explosion, as they mentioned before. Where is it? Here it is. As we read before, momentum, conservation of momentum in collision. We have studied about collision, and now explosion. Explosion too involve momentum. Example, it could be anything lah that explode. It could be anything. Let's say we have you like to play, what is this, firecracker? Firecracker it is. There is a little what to call this, then you light this up. then it goes like this, and kedapam, boom. Guess what? Let's say it divide to two parts. It explode to two parts. One go that way, okay, and one go that way. Okay, like that, nah. Okay, boom, kedapam, boom, like that, boom. Okay. How to put effect like that. Okay. You got the idea lah. Boom. So, you know what? We're going to understand the same thing as the collision. The idea is we're going to count. We're going to count the total. This is before incident, and this is after the incident. Okay. The question is this momentum before explosion, and is this the total momentum after explosion? Will they both have the same momentum? If they have the same momentum before explode and after explode, this proves to us that the explosion too obey the principle conservation of momentum. You got the idea? So the idea is next we're going to do some arrangement of mathematics. We're going to find out either this total momentum before explode. Okay, as you can see down there in blue box here, is it the total momentum before explosion equal to total momentum after explosion? Okay, from this understanding is when we derive the formula. So let me ask you, what is why zero here? Why zero here? They can already know the total momentum of before the explosion. How do they know that this is zero? The momentum of whatever it is that explode is zero before. How do they know? So you see, before this explode, it got no motion. They at rest. They just they just stand at there, do not move. So you know, whatever multiply. Coming back to this formula. So you see, this u here and this u here is zero because they didn't move. So from mathematics, you understand that whatever multiply zero is equal to zero. This also zero, plus this also zero. 0 plus 0 is 0. So the idea is, when come to something explode, you do not have to write it down like this. You just come directly to 0. Because we know already the total momentum before things explode is 0, because they got no motion. Okay, this is why they put 0 already on the left side, while on the right side never put 0, because after it explode, we tend to see that the things got separate like this. yeah, actually they going to separate many things lah, many parts. It could be 1,000 parts when it's explode, but for this level they only uh, take it as separate to two parts only. Yeah, okay, it's explode and separate to two parts only. Yeah, okay. So this is why we have M1, here is M1 and here is M2. Okay, after the explosion we have M1, we still have M2, because one body now after explosion become two body. So this is why we have M1, M2. Okay, but you know what, maybe they go with different velocity. Maybe this velocity different than this, is why they also need to have two different velocity, V1 for M1 and V2 for M2. Okay, so the idea is we're going to find this momentum by taking its mass multiply with its velocity, and also we're going to find this momentum by taking the mass multiply with its own velocity, and then we combine both momentum, and this is why we get this formula like this. And this on this downside here is the algebra lah. Okay, actually I just want you to refer to this formula only, because this, or whatever it is you want to find M1 and you want to find V1, or you want to find M2 or V2, one of the component at a time, you can do the algebra transfer, correct? Okay, according to what you want to find. So you just need to focus more on this only. If you want to find what it is, what is that, what is the component of this, what will happen to that, the velocity, or whatever the component you want to find here. You know, let's say you want to find the value of V1 here. You got all the value, then you do the algebra transfer, correct? It's mathematics only. It's mathematics only. And so doesn't this rocket resemble explosion? They both actually this rocket coming from one body. So after it release the hot gas downwards, so this is explosion. Actually this is explosion. What happened in back there is explosion. When explosion happen, it kind of separate one body to two body. One body is the rocket itself go upward, while the second body is the gas field inside the body coming out. So it is kind of explosion. Okay, so in order to find what M2 V2 or what M1 V1 is, you're going to have the same, you're going to refer to this same arrangement of formula lah, that you just you understand from the conservation of momentum of explosion. Okay, that is the idea. Okay, and then you know what, we end up the topic with formative practice. Okay, you can do this practice, or do you want to do together together? Okay, let's do this. What is meant by momentum and conservation of momentum? We're not going to do that. You're going to do that. Sorry, I'm not going to do that. You find it out here, the sentence which talk about the momentum, where is it? What is meant by? Okay, you find it yourself lah. Maybe you look at the answer on the back. I just want to focus on how to use the formula. So let's skip to question number 2. A lorry of mass 100,000 kilogram. As usual, please put a value. Since this mass refer to lorry, ml, ml moves at a velocity of 5 meter, blah blah blah, whatever it is. Okay, v. Sorry, because this is referred to initial velocity, then we put u, like that. It collides with a car of mass. See, collides mean, is it the story about momentum or not? About principle conservation of momentum or not? We got the quick idea. It must involve the principle conservation of energy when it comes to collide or explode. You know the idea already. With a car of mass 800 kilogram, mc for mass of car, moving at a velocity of 2. This also u, because initial velocity for car uc, uc. Okay, in the same direction. In the same direction means that they both go the same way. This is car, this is a lorry. Okay, before collision they both go same way. But guess what? This lorry got no manner. Got no manners. He speed up until it can reach, it can chase the car and it hit it. Okay, in the same direction. If the lorry moves at a velocity of this 3.4, higher than the car velocity of car, this is why the lorry can chase up the car. If the lorry of if the lorry moves at a velocity in after in the same direction after the collision. After this refer to velocity of lorry after, then we can use v instead of u. VL lorry, VL in the same direction of the after the collision. Calculate the velocity of the car. This time they want you to find velocity of car. What is the symbol that we supposed to use? VC. V, because initial velocity after collision of car, VC. So how to begin? Where to begin? So the idea is this story involves principle of conservation of collision. So when we say principle of conservation of collision, this is what supposed to come out of your mind, this formula. That is, so I'm going to write this formula before we tend to do any substitution. U1 plus M2 U2 equal to M1 V1 plus M2 V2. Don't worry, it looks a little, so long, the formula is so long, but guess what? If you do lots of exercise, you will get used to it. You will memorize them already, simple one. Okay, and then you know what? This one refer to lorry, correct? While these two refer to car. So take this chance to what to change the symbol UL plus M C U C equal to M L V L plus M C V C, like that. Okay, it doesn't matter if you want to put a level for lorry M1 L1 as M1 here, depend on you lah. Okay. Okay, what question need us to find? Question 1 need us to find the value of VC, VC of the car. Okay, here it is. The question want us to find the value of VC, and here it is VC. So we are given all the value, correct? We are given all the value except this VC. How to find VC? Back to mathematics. You do algebra transfer until you get the value of C on the left side, while other component that we know already the value you put on the right side of this symbol equation. So how to get VC on the to leave VC on the right side? So we take this to left side, so it become going to quite a lot of work that we need to do here. You know what? Never ever substitute the value before you do the transfer, because it's going to be long. So take this chance to transfer, to do algebra transfer. Okay, this we take there, and it become M L U L plus M C U C. Okay, minus this, minus this M L V L equal to MCVC. Okay. Okay, we only want to have VC on the right side. Means these two need to take out and transfer to the left side. So it become MLUL plus MCUC minus MLVL divide by all of them, divide by MC. What is left is VC only. So you can, you know what, you can flip this. So we have VC equal to this time you take a chance to substitute all the value. ML is, where is ML? 1,000 kilogram. Okay, 1,000 kilogram multiply with UL, refer to this 5 meter per second, 5 meter per second, plus MC, refer to this 800 kilogram, multiply with UC. UC is 2 meter per second. Okay, minus ml. ml refer to 1000 kilogram, multiply with VL. VL refer to this 3.4 meter per second. Notice that all of the unit presented is in SI unit already, yeah. So we'll have no mess about the unit, divide by all of these, divide by MC, which refer to the mass of car, 800 kilo. Okay, 800 kilo. Wow. What a lot of mass we need to. Okay, let the apa nama ni, let the calculator do a job, correct. Sometimes we can calculate it directly, like this. 1000 multiply 5, we get 5000 Newton second plus 800 multiply 2, okay, Newton second, minus 1000 multiply this 3.4, 400 Newton second, like that. Okay, multiply with 800 kilogram. Okay, I'm running out of paper. Don't worry, I got another paper. Say, continue. Okay, 5000 plus 600 ID. You do let the calculator do a job. Simple thing you can count on your mind only, but if complicated, do not mess your mind. Just have calculator do job for you. 5000 plus 1600 minus 3400. Okay, divide by 800 kilogram, and all that is left is 4. Okay, all that is left is 4. Okay, how to get the unit? So we have, sorry, okay, never mind. Again, we have 4. How to deal with unit? Because we have this unit, correct? Newton second divide by kilogram. Okay, and we know Newton second is the long unit for Newton second is kilogram. Meter second negative 1, correct? So you see, this kilo we can eliminate with this kilo. So all that is left is only this, which we come to know already, that this unit belong to what quantity physics? It belong to velocity, as it is, as what we want to find. VC, V here, velocity, for meter second negative 1 whole. And here it is, ta-da! The final value that we need to find. So the idea is, this car, after the collision, after the lorry hit him, this car will thrown forward. with this velocity 4. Before this car is at this velocity 2. After it been hit, it raised to 4. So how dare the lorry, how evil the lorry. No, maybe the lorry got a problem, brake problem. Okay, they always do have brake problem. 4 meter per second. Okay, okay, that is how the situation which involve this momentum to find anything about this momentum, when to use this formula, and so on lah. What happened before, what happened after, will the momentum preserve? Okay, you continue your exercise about momentum on workbook. In workbook there are many exercise to test your understanding of concept. Each of the concept, they have their special exercise on workbook. Okay, force, you know what, we have this 8 minute left. Anything you want to ask me until now? No, if no, let's use this time to learn this force. We going faster as we can. So what is force? 2.6, what is force? Most of our daily activities involve forces. A force can change the state of motion of an object. Do you understand this one? I believe you come to know the force in Sine Form 1, is it? You know the force already, How to make this force? Somebody, how to make this force? What is your idea? How to make this force? We can make force by many ways. Example, we can make a force by what to call this? What is it? Jentik apa dalam bahasa ni? Terjentik. We pinch, pinch. We attract, tarik. We kick, tendang. We kick. We push, push. We pull, tarik, pull. We apa lagi? They are, so you see, you have learned how to make force, how to make force. There are many ways to make force. Okay, letak bom kau sini, bom letup, boom, make a force. It could be many ways. So now we want to we come back to learn about force. This time is more detail about force and what this force can do. What force can do? Force can tear a piece of paper. This is what force can do. Correct? Force can cram the paper like this. Okay, I use my finger here and put some force on a piece of paper. This is what happened. This is what force can do. Okay, force can tear. Okay, like that. Force can make make what? So many things can do. This is what force can do. We got a ball here, football, and you kick, boom. This is what means that the ball is at rest. Okay, at rest, no motion. If exert a force, we put a force on the object, what happened? Boom. It can set a motion. It can set all the object that is rest, it can start moving the object. Correct? This is what they tell you. A force can change the state of motion. Okay, we can do the opposite way. This ball is in a motion, let's say like that, and sometimes and suddenly someone come and kick it the opposite way. Boom, let's say like that. This is what force can do. The force also can stop moving object. Stop like that. Boom. See, it can move object from rest. It can stop the object from moving. Okay, how does a force change the momentum of an object in motion along a straight line? This time they're going to relate force and momentum. They're telling us what force can do to momentum. Okay, how force change the momentum of an object. Okay, so coming from this question, follow by this question is this activity 2.13 here. Okay, to show to you what force can do to momentum of this object. You know momentum already, how to find momentum of this object. You take the mass, you multiply the velocity lah, correct, to find the momentum. But you know what, how force can affect this momentum? Means that can we increase this momentum of this object? How to increase this momentum? How to increase this momentum? By using force. Okay, we cannot do something about the mass of this object because we got only one trolley here. Okay, and force got nothing to do with adding or minus the mass of the object. But force can do something on the velocity of this object. When velocity change, that you know already, the velocity change multiply with the same mass, then we will get different momentum. Correct, we will get different momentum of the object. So this is why it can be related, how force will affect the momentum. Okay, that soon we'll come to study about this. So we running out of time. Only got 1 minute. I just introduce you the next chapter, so you will get ready. Maybe you want to read all of them. Read all of them. Okay, until we meet again. You read first, it will make you easier to understand my explanation, my teaching. Okay, the time has end. Assalamualaikum.